very small questions about force sharing. As you know, it's alright because you have a long array and you compute massively this array, and you don't see there is force sharing.
That's right.
Because force sharing is a problem of architecture.
That's right.
Cache line is contain your array, and you write massively in this cache, and there is a lot of synchronization with memory.
Yes.
My question is, do you think you can improve the tooling in Visual Studio to show there is for sharing?
Yeah. It's a great question. So, people ask about false sharing a lot, and what we've seen is when it goes wrong, it really goes wrong. Like, you really have some bad cases, and in fact, I've got a program. I think it's probably 10 lines of code, and it's a .NET program too. It's not even like hairy C++ code, but it's about 10 lines of code that shows how declare a variable here instead of here, and you get really bad false sharing characteristics because you have two threads that are basically writing to two different things in the same cache line, and invalidating each other and causing the cache to refresh every time. So so one, when it goes wrong, it goes really wrong. But two, it doesn't go wrong often, such that it affects the broad execution of a program. So what we find is that for, call it compute kernels, you have a computation kernel where performance is really sensitive, and you can, and if this is a core piece of foundational execution component that's deep in your software, that could be really important. Sometimes you have things that are kind of on the periphery that get executed once in a while, and so when you get some of these false sharing, you get a 10% performance degradation in some cases. In really bad cases, you've got this kernel and you get a 75% performance degradation in these really key cases. What we found is that, and one of the reasons we focused on this sort of more big picture ink blot type of thing in this version is we found that by far the biggest reason why people go wrong is it's algorithmic.
Yeah.
They're just doing the wrong thing. They're doing the wrong thing relative to locks. They're doing the wrong thing relative to parallelism, just from a very gross algorithm standpoint, or memory allocation, or some very big thing. As you start to drill in, you find, okay, once you've kind of solved that, and then the profiler says it's all green. Great, it's all green. I'm spending all my time executing now. Then the question is, okay, well, green isn't necessarily virtuous, right? It just means the CPU is busy. It doesn't mean it's busy doing what. And so as you drill into what that green looks like, that's where you find that you want to look for things like false sharing, or even if you have something like spin weights in your code, those show up as green. Yeah. And it looks like, from a high level profiler standpoint, it looks great. All my my code is running. Right now, I think the best set of tools to look for those kinds of errors are things like Intel's Parallel Studio or Intel's vTune, which lets you get really down deep into the level of performance counting.
You can see oversubscription, and you can confirm there is a problem with the kind of cache line, but it's not so easy to see. That's right.
It's very difficult to see, and it's very difficult to know. Based on performance counters, it can be very difficult to know. This is something that's false sharing, or this is normal behavior. Yeah. And there's you can actually turn on vTune and say, okay, well, I'm interested, and I forgot what the little bits use. It's like second level cache, misretire. They have some weird words that they use for it, but within vTune there are some specific things that you can look for in order to detect false sharing. But there's no big blinking neon light either that tells you that this is your problem. Yeah. So I think in Visual Studio, we're probably much more likely to help people on these broader scope, bigger picture things to help people with the design of their application. I think we'll continue to work with partners such as Intel to get the very low down, close to the metal things like you would find in vTune. Within the Visual Studio proper profiler, we're always adding a little bit more, and I know that's a different team within the Visual Studio organization that works on the profiler proper. and they're always looking for new things to add. And I don't know. I haven't heard that they're planning to add things like false sharing detection. I would be surprised because in many ways they're focused on more broad application. What are my hot paths? How can I optimize? So I think, long story short, in the near term, I would look to partners such as Intel to serve that need.
Okay. Do you think if this first version of Visual Studio with parallelism, it will be a success or not about parallelism?
I think so. Parallelism is something that, whether developers like it or not, we have to care about now. The fundamental nature of the hardware has changed.
Yeah.
It used to be we can rely on the hardware increasing clock frequencies at a steady rate, and our software would just get faster. I could buy some software today. When I ran it on tomorrow's machine, it would be faster. That's no longer true, and in fact, my machine last year sometimes is faster from a sequential execution than my machine this year, depending on which one I bought. Not always true. But the machine I buy this year probably has more cores and probably has smarter usage of those cores, such that when I'm running several workloads together, I get better throughput. The result as a software developer is that I have to care about that now. I didn't really used to have to care about that, but now I have to care about that. I have to find some ways where I can get performance increases from parallelism. I have to find ways to use that. So I think in many ways developers are compelled to care about parallelism just because the hardware's changed. So our jobs the playing field is different than it was a couple of years ago. When I look at what's being offered in Visual Studio 2010, it's by far the most complete stack available in the market. If you look at what's available in tools, what's available in managed versus native code, the core execution platform, debugging, profiling. We've started to even add some multi-machine capabilities, so we can debug MPI applications now running on Windows HPC server. And so as people look to scale out their programs as well to get maximum performance for really data-intensive or really computation-intensive workloads, we support that within the regular Visual Studio toolset now. So I think it's very complete. I think, relative, if you look just from a language standpoint in the programming models, compare that to what you see in Java, or kind of any of the mainstream programming languages, I think it compares really favorably. You go to the tool side, you kind of compare that with what's in Eclipse, other tools, pretty strong offering. Complementing the offering, again, I mentioned Intel Parallel Studio a little bit earlier. They integrate really, really well with Visual Studio. If we look at what NVIDIA is doing on the GPU front with CUDA, their tools integrate with Visual Studio as well. So they're, not only is there a lot within Visual Studio, but their third-party ecosystem is filling in those areas that Visual Studio itself doesn't maybe have an offering in some area or a strong offering in some particular area. So I think as a whole, I expect developers to pick it up pretty enthusiastically. I expect developers to, kind of cut themselves on some of the sharp edges of parallelism. One of the areas that we haven't talked about, particularly when we talked about the life cycle, is correctness. And correctness is a super important area where, I wrote my code, but gosh, how do I know it's right? How do I know I don't have like a race condition that's a variable's changing where it shouldn't, or a deadlock that is latent that I'm not seeing in my testing, but it's going to show up with my users. And so for that's an area that's important. It's an area that right now Intel Parallel Studio has some technology that helps with that in terms of some dynamic analysis technology that they can instrument your program, you run it, and then you can say, I have some races, I have some deadlocks. For us, for the next version of Visual Studio, it's an area we're looking at deeply. Is there some stuff that we can do there to complement what's in the ecosystem, so that developers can be more sure, like, it's really easy to use tasks, but it's also can be a lot easier to do the wrong thing. So can we provide some guardrails so that when developers leverage parallelism, they can do it knowing that they're more likely to be doing the right thing when they are doing it?
Great. Very great. I would say thank you very much.
Oh, thank you. This is great.